When we observe the universe with the most powerful telescopes, we see an astonishing number of galaxies, cosmic islands, each containing hundreds of billions of stars. In the known universe, there are thousands of billions of galaxies, and we see them at all distances and in various stages of their evolution. We can study them, catalog them, reconstruct their distribution, and even their history. We ourselves are part of one of these cosmic islands, the Milky Way. However, we are immersed within it and therefore cannot observe it from the outside. How did we come to understand what the Milky Way is like? What shape does it have? What is its history? Let's try to understand. Our star, the Sun, is part of a galaxy called the Milky Way. We are immersed within it and in a specific position within this galaxy. So, understanding what our galaxy, the Milky Way, is like is not straightforward. We cannot observe it from the outside, and the stars we can see with the naked eye are only a few thousand. We can notice that we are inside a galaxy because when we look at the sky, there is a region, a brighter band where more stars are concentrated. Today we know that this band is the disk of our galaxy. However, for a long time in ancient times, it was not easy to accurately reconstruct the distance of the stars. In fact, for a long part of the history of astronomy, it was almost impossible to know how far away the stars we see in the sky are. Therefore, there was no way to have a three-dimensional perspective of the galaxy we are part of. The first actual map of the galaxy was drawn in 1785 by William Herschel, the astronomer who also discovered the planet Uranus. Herschel essentially counted all the stars he could see in different directions of the sky and reconstructed a map that was, in reality, an approximate map. Today we know that it was an incorrect map, also because it was based on incorrect assumptions, such as the idea that all stars had exactly the same brightness. This skewed the result. For example, in Herschel's map, the Sun was placed at a central position within the galaxy, which we now know is not true. But this knowledge has only been acquired recently, essentially since the early 20th century, when more accurate observations with telescopes began and a clearer idea of the true shape of the galaxy was gradually reconstructed. Today we know that the Sun is not in a central position within the Milky Way, and we also know that there are many other galaxies. Our galaxy belongs to a particular class of very common galaxies, spiral or disk galaxies. How did we come to understand that there are other galaxies beyond our own? It's a very interesting story in itself, but I might tell it another time. Anyway, a spiral or disk galaxy is named so because it has a flattened shape, with a central region, a bulge, a denser core surrounded by a thinner region that also contains elongated arms, similar to those of a pinwheel. The Sun is located in one of these arms, on the outskirts of the Milky Way, about 28,000 light-years from the galactic center. The galaxy has a diameter of about 100,000 light-years. Now, as you know, there is a very fascinating concept in astronomy that is well known and widely used. We've talked about it many times here on the channel, namely that the speed of light, which is 300,000 km/s, is a finite speed. This means that light takes time to travel between 2 points in space. When we look at distant objects in the universe, we do not see them as they are now, but as they were when the light started its journey. If we look at an object millions of light years away, we see it as it was millions of years ago. Thus, at any moment we can observe old snapshots of the universe simply by looking very far away. However, when we look at nearby or relatively close objects on a cosmic scale, this time machine trick doesn't work as well. Specifically, when we observe stars that are part of our galaxy, the delay is not so great as to give us information about how things were in very distant times. This creates difficulties if we want to reconstruct the history of how our galaxy formed. Naturally, we think we know how other galaxies formed, because we can observe very distant galaxies at various stages of their evolution, and we have many theoretical models that tell us how galaxy formation occurred. Thus, presumably, this is also how the formation of our Milky Way occurred. These models tell us that galaxies form because material, filaments of gas and dust, increasingly clump together within these structures, and stars ignite. However, being immersed within our own galaxy makes reconstructing its history more complicated. Many stars have been born and died since the galaxy formed. The material that makes up our galaxy and the interstellar material between stars has changed a lot chemically, because generations of stars have succeeded each other and left the elements produced within them in the surrounding space. Moreover, the movement of stars themselves, which are not fixed in place but move within the galaxy, has stirred everything up. So it is very difficult to determine the exact place of origin of a star, even of our own sun. Many valuable pieces of information about the history of our Milky Way have been lost forever, making it very difficult to understand how things stand. However, this does not mean it is impossible. In fact, astronomers, especially in recent decades, have made huge strides and invented very ingenious methods to trace back the history of our Milky Way. A huge leap forward came about 10 years ago when the European Space Agency launched a satellite called Gaia. What is Gaia's goal? Gaia's goal is to map our galaxy by observing with great precision the position of an enormous number of stars in the Milky Way and reconstruct not only their position but also their distance. Essentially, Gaia has been performing a three-dimensional mapping of the Milky Way for 10 years. Not only that, it does other things as well, but this is one of its main objectives. Imagine that the precision with which Gaia can reconstruct the position of a star in the sky is just 24 microarcseconds or 24 millionths of an arcsecond. To give you an idea, it's like seeing the size of a coin on Mars or the thickness of a human hair from 1,000 km away. It is truly an enormous precision. Gaia has managed to measure the position of almost 2 billion stars in our galaxy. Now, considering that the total number of stars in our galaxy is around a few hundred billion, this is an enormous number because it is about 1/100th of the total number of stars in our galaxy. To give you an idea, the first catalog with a historical record of star positions in the sky, made by the astronomer Hipparchus in the 2nd century BC, contained just 850 stars. Just 30 years ago, a satellite called Hipparchos, also from ESA, managed to compile the positions of 100,000 stars, a number that at the time seemed enormous and represented a gigantic step forward. But now, with Gaia, we are at nearly 2 billion. An even more extraordinary thing is that Gaia has not only measured the positions of the stars, but has also measured the distance and movement in the sky for almost all of these stars, a fraction exceeding 90%. Therefore, Gaia has created a three-dimensional map of our galaxy that is also a dynamic map, as it provides information on how stars are moving today. To some extent, we can try to rewind the film and understand from the speed and direction in which stars are moving today what their trajectory was in the past. It's a bit like observing star currents in the sky, and by reversing the motion of these currents, trying to understand where they were in the past. What have we understood? The results from Gaia are extremely important. Moreover, not all the data has been fully exploited yet, but many things have already been understood in the past 10 years. One of the discoveries is that the structure of our galaxy is the result of mixing and collision with other smaller galaxies, like the dwarf galaxies that have interacted with ours in the past billions of years. For example, there is a small dwarf galaxy called the Sagittarius galaxy that in the last 5 billion years is thought to have crossed the disk of our galaxy at least 3 times. This is evident because we have observed that the shape of the disk of our galaxy is distorted, and the way the disk orbits still feels the waves caused by the passage of this smaller galaxy. It is even thought that the formation of our own solar system was triggered by one of these collisions, with the shock wave initiating the collapse of the nebula from which the Sun and the solar system formed. Gaia has observed the aftermath of many other similar events, such as collisions and mixing, which contributed to the formation of our galaxy as we see it today. One of the most recent results, released a few months ago, shows, for example, that there are 2 ancient structures, now towards the center of our galaxy, made of stars that are 12-13 billion years old, nearly the entire age of the universe. These structures might have been the first components of the Milky Way and have been named Shakti and Shiva, names inspired by Hindu mythological deities who gave birth to the universe. These structures appear to move in a coordinated manner like star currents and contain a mass corresponding to about 10 million times that of the Sun. The stars within them seem to have very similar chemical compositions and lack heavy elements. Heavy elements are formed inside stars, so the oldest stars, the first-generation ones, did not yet have those heavy elements. These structures thus seem to be made of stars born in an era when the universe was still very young. All these clues suggest that Shakti and Shiva might indeed be 2 primordial building blocks of our galaxy's formation, so ancient that the disk structure we see today had not yet fully formed. These are just a few examples. The interesting thing is that thanks to observations like those of Gaia, we are now able to reconstruct the history of our galaxy and its shape more accurately, without leaving the position we occupy. Through these studies, we are able to rewind the tape and better understand galaxy formation models in general, and in particular the formation of our cosmic island, the Milky Way. Thank you for watching. Leave a supportive like and subscribe to the channel.